This video is a review of step functions. So remember, a step function actually has little steps in it. Okay, so it's in the form y equals a times the greatest integer, remember that's those brackets, bx minus h plus k, where a represents the height between the steps, so the distance between the steps can increase or decrease. So if you multiply it by a whole number, such as 2, the distance between the steps increases 2 times, or times 2. B, if it's multiplied by x inside the greatest integer bracket, it represents the length of the step, so the actual length the step is. So it could get longer, it could get shorter. H represents the horizontal shift in the graph. K is the vertical shift in the graph. And so y equals the greatest integer. So remember, that's greatest integer, so it's the greatest integer function. To solve, find the largest integer less than or equal to the value inside the brackets. And to graph it, you're going to create a table. So let's do a couple of practice ones together, and then I'll let you try some. Okay, so the first one, let's just do the parent function, y equals the greatest integer of x. So I'm going to create a table where I'm going to plug in some x values and get y values out. Okay, I'm going to start at 0. I'm going to include some decimals halfway between a number so you can kind of remember what's happening in greatest integer functions. So 0.5, 1, 1.5, 2, and I'm going to do one more just so you can get an idea of the pattern that's occurring, and then you can continue the graph. And 2.5. Okay, so if we plug in 0, greatest integer of 0. Okay, so remember, find the largest integer less than or equal to the value inside the brackets. Well, since 0 is an integer, it just equals 0. Greatest integer of 0.5. So the largest integer that is less than or equal to 0.5 is still 0. So if I plugged in any decimal all the way up to 0.9999 repeating forever, the greatest integer of it would still be 0, because that would be the largest integer that is less than or equal to its value. Okay, so now we're going to move on to 1. Greatest integer of 1 is just 1, because 1's an integer. Greatest integer of 1.5. Well, the largest integer that is less than or equal to 1.5 is 1. Greatest integer of 2 is 2, because it is an integer. Greatest integer of 2.5. So the largest integer that is less than or equal to 2.5 is 2. So everything up to 2.999 repeating forever would equal 2. So everything up to but not including 3. Just like from 0 all the way up to 0.9 repeating, the output would always be 0. So from everything including 0 up to but not including 1, the output would be 0. And so remember, when it does include the value, you put a solid circle. When it's everything up to but not including the value, it would be an open circle. So I know when x is 0, y is 0, and it includes that point. So all x values from 0 up to 0.99, repeating forever, the output is always equal to 0. So all these points in here. So everything up to, but not including to where x is 1. So this is a filled-in circle. This is an open circle. Okay, so I'm going to try another one. When x is 1, y is 1. It includes that point. Everything up to, but not including 2, so this is an open circle, the output would be where y is 1. So remember when x is 2, y is 2, so that's why it's an open circle, because we have to start a new point up here. So when x is 2, y is 2, everything up to, but not including where x is 3, y is going to be equal to 2. So see how it's a step function because you have these little steps. And now that we know the pattern, you just continue the pattern going up. So keep going. And just make sure you can tell which side is closed, which side is open. And not only do you need to continue it up, but also continue it down. And don't get confused when you're going down. My left side's closed, my right side is open. And it will continue. Just a couple more. And last one. All right. So that's the most basic type of step function. So now this one, its absolute value, or the greatest integer of x plus 1. So that entire thing is inside the greatest integer bracket. All right, so I'm going to create a table. I'm going to do this one below this time. So we have x I'm going to plug it into greatest integer of x plus 1. My brackets are not perfect, but that's okay. And I'll get out y. So I'm going to create the table. Again, I'm going to choose values 0, 0.5, 1, 1.5, 2, and 2.5, just so we can see what's happening between the integers also. All right. So I'm going to start by plugging in 0. I'm just going to simplify what's inside because the whole thing's inside the bracket. So we have the greatest integer of 0 plus 1 is 1. Just going to fill in the middle column and then see what it equals. So the greatest integer of 1 is just 1. Okay, now I'm going to plug in 0.5. So greatest integer, 0.5 plus 1 is 1.5. And the greatest integer of 1.5 is 1. Because remember, find the largest integer less than or equal to the value inside the bracket. All right, now plug in 1. 1 plus 1 is 2. Greatest integer of 2 is 2. Plug in 1.5. 1.5 plus 1 is 2.5. Greatest integer, so the largest integer less than or equal to 2.5 is 2. Plug in 2. 2 plus 1 is 3. That bracket wasn't very good, but that's okay. Greatest integer of 3 is 3. Plug in 2.5. 2.5 plus 1 is 3.5. Okay, so greatest integer of 3.5 is 3. So you can see that before, when we chose the same x values, we got out 0, 1, and 2. And because this one, we have a shift that's happening, our output values are 1, 2, and 3. You can see that there is a difference of 1 in these opposed to the parent function that was the most basic type of function. So we're going to graph these. All right, so when x is 0 all the way up to, but not including where x is 1, the output is 1. So remember, open circle it where x is 0. Sorry, closed circle where x is 0 because it does include it. Open where x is 1 for an output of 1. So let's see. When x is 0, y is 1. All the way up to, but not including where x is 1. So that one's open. Okay, then when x is 1, y is 2. All the way up to, but not including where x is 2 down here, we can see. So 1 all the way up to, but not including 2, the output is 2. 2 all the way up to, but not including 3, the output is 3. So 2, when x is 2, y is 3. All the way up to, but not including where x is 3. So again, we have one end where it's the closed circle, the other end is open because it does not include that value. And just like before, continue your graph going up and going down, because you can, as soon as you've plotted a couple of the steps, you can always identify what it's going to continue looking like. And so when you go down the other direction, just be careful that you remember which side. Keep the solid dot on the left, the open circle on the right, and continue till it fills up your graph, because the step function will continue. Whoops. All right. Okay. So you can see that they do look slightly different because of that shift, the +1 inside. Okay, so remember, when it's inside, it is a horizontal shift, and it would be shifting it 1 to the left, and we can see how that one was shifted 1 to the left. All right, so you have a couple of functions that I'd like you to graph. So go ahead and pause the video here, come on back when you're ready for the answer. All right, so this first one, the -1 is outside. So I'm going to create my table. We have x and y. All right, again, I'm going to choose 0, 0.5, 1, 1.5, 2, and 2.5. Okay, plug your x values in. So greatest integer of 0 is 0. 0 minus 1 is -1. Okay, greatest integer of 0.5 is still 0. 0 minus 1 is -1. Plug in 1. Greatest integer of 1 is 1. 1 minus 1 is 0. Plug in 1.5. Greatest integer of 1.5 is 1. 1 minus 1, 0. Plug in 2. Greatest integer of 2 is 2. 2 minus 1 is 1. 2.5. Greatest integer of 2.5 is 2. 2 minus 1, 1. So then I'm going to graph. So when x is 0, y is -1. And all the way up to, but not including where x is 1. When x is 1, y is 0. All the way up to, but not including where x is 2. When x is 2, y is 1. All the way up to, but not including where x is 1. So we have created a pattern that we can identify and continue it on up. Just make sure you can identify which side is the closed circle to represent that it does include that point. It is equal to that value. Open circle does not include that point, so it's not equal to that value. Almost done. All right, and the other one, last one. Okay, again, we have x values and we get out y. Okay, I'm going to plug in 0, 0.5, 1, 1.5, 2, and 2.5. All right, plug in 0. 0 minus 3 is -3. Greatest integer of -3 is -3. -3 times 2, -6. Plug in 0.5. 0.5 minus 3. If you need to do the math over here, you can. So we're at -2.5. Greatest integer of negative 2.5 is negative 3 because negative 3 is the largest integer that's less than or equal to negative 2.5. You can always look at a number line if you get confused. So negative 3 times 2 is negative 6. Plug in 1. 1 minus 3 is negative 2. Negative 2 times 2 is negative 4. Plug in 1.5. 1.5 minus 3. So we're at the greatest integer of negative 1.5. This is where some people get confused. So you can look at a number line. So if I had 0, negative 1, negative 2, negative 1.5 is halfway in between. You can say, well, I know that the largest integer that's less than or equal to negative 1.5, which is here, would be negative 2. That's why looking at a number line does help. So this equals negative 2. Negative 2 times 2 is negative 4. Okay, plug in 2. 2 minus 3, negative 1. Greatest integer of negative 1 is negative 1. Negative 1 times 2 is negative 2. Plug in 2.5. 2.5 minus 3 is negative 0.5. Greatest integer of negative 0.5 is equal to negative 1. Because remember, negative 1 is the integer that is exactly smaller than that one. It can't be larger than it. 2 times negative 0.5 is negative 2. So now that we have this, we can go ahead and graph. When x is 0, y is negative 6. All the way up to, but not including when x is 1. Right? So when x is 1, y is negative 4. All the way up to, but not including where x is 2. You notice how it jumps 2? That's what the times 2 on the outside does. It increases the height of that step 2 times. So before it jumped 1, now it jumps 2. All right, so when x is 2, y is negative 2, all the way up to, but not including where x is 3. And so we can continue this pattern going up where it's skipping 2 of our y values each time. Again, because of that times 2 on the outside. Okay, and then continue it going down. And the last one. All right. Hope you remember how to graph step functions, specifically greatest integer functions.